You ready to get started? Okay. So I did change the title a little bit here. I typically do this. Put out the submit to do a talk, and then change the title slightly just to make sure it fits what I'm going to talk about. This is a lot closer to what I'm going to talk about today. Building the Internet of Things with HTML5 and Node.js, which I took embedded JavaScript out of there because that was a bit confusing about EJS, and what I really meant by embedded JavaScript was running a JavaScript on an embedded Linux microcontroller. So just to clarify a little bit. My name is Jesse Cravens, JD Cravens and Jesse Cravens at GitHub. Probably should have made those the same, but I didn't a long time ago. I'm a local web engineer here to Austin, and the co-author of HTML5 Hacks for O'Reilly. I brought a couple copies today, and I've got some in the car. If anybody's interested, I'll sell you a copy. But I also want to give one away to anybody that can answer a question out of the book. So that's just a general HTML5 specification question. So how many of you guys are aware of or familiar with server-sent events? Okay. First person who can answer what the client-side object is that you create to make a connection to a server-sent event gets the book. Nope. Really? I didn't know if this was going to be a difficult question or not. Anybody want to cheat or something? Look it up on your phone or? Well, let me just try to come up with another question real quick. Event source. Correct.
I totally cheated, but I'll take the book. It's okay.
I would have cheated too. Okay. Yeah, event source is the answer. Really simple API. I work for a great company called Frog. We are 1,600 individuals in these global studios around the world. We're made up of researchers, strategists, designers, and engineers, so interdisciplinary teams, and we bring ideas to market for companies such as these here. If you have any questions about Frog, I could talk about Frog all day. I love working there. It's a very creative environment, and we have a lot of fun, and we build some really cool stuff. So just grab me afterwards or anytime. I'd love to talk to you about it. We're always looking for good people. So again, slight change to the title, but the gist of it is the same. So 2012 for me was number one, writing this book, and in the type of work that I do in the web space, was a lot of decomposing these specifications into what I call hacks in this book. That's what I did for the book, right? It's taking these specifications and breaking them down into units of work or something that you can work with so you can understand the spec, and then you can figure out how to use it in an application or in some larger system. Doing that, I'm sure there's some authors in here. You all know that it's a lot of work, and at the end, you're kind of wanting to do something a little bit different, maybe. And so I set out to find something that was a new challenge, but was something different but complementary to what I was doing already, and fun for the whole family. I spent a lot of time. A lot of nights and weekends writing and not spending time with my family, so I thought, well, maybe I could do something with my soon-to-be 6-year-old son and my brother, and maybe even something that my wife could get into. So I set a couple of goals, and I really was just kind of yearning to do something with this concept, the Internet of Things. How many of you heard the concept Internet of Things? Okay. I don't know if y'all want me to go into that, but basically the idea is that connected devices, everything that you own Future state would be everything would be connected to the internet, including yourself. Everything's collecting data, and we just live in this huge mesh. I don't think we're too far away from it today, but it's just going to continue to evolve. I wanted to use open hardware and open web technologies because that's just who I am and what I enjoy. I'm not really a proprietary kind of guy. And I firmly believe in it. I'm a self-taught engineer, so if without the openness of the web, I wouldn't be where I am today. And I just love the mentality. I wanted to keep the costs reasonable in building my Internet of Things, which you can quickly spiral out of control with this stuff. As you'll see, I'll start showing you some microcontrollers and some equipment. And I wanted to create real homegrown data. This is something that you're constantly working with other people's data in your regular jobs. I wanted to create some data at my house, right, or in my project. And then I wanted to learn, teach, and share, and that's why I'm here today. In other words, I didn't want to write any C or Python, although I do, and I'm probably going to exaggerate this because I really do have an interest in learning all types of programming languages. But for the sake of a conference like this and for the sake of JavaScript developers, I tried, and I'm still trying, to use as much JavaScript as possible within my Internet of Things. And the data, you're going to see some of the data I'm creating. You're going to question whether it really is all that important, but I can pretend that it is. And then I wanted to find the right mobile environment to house this big prototype. A lot of people are doing, home automation, and I thought, well, that's cool and all, and very appealing to me. But I wanted something that could move around, and something that I could kind of deck out and then move it around. So I've always been into camper vans, but I can never fit in them. I'm kind of a tall guy, and this is really cool, but it just wasn't going to work. This was perfect. This is what I would have if I could have gotten it past my wife. Right? It's tall in the back. It's rugged. It can go anywhere. Maybe, I don't know, but it would have looked really awesome in front of my house, and she wouldn't fly in with that. This here is a Unicat. I don't know if anybody's seen these. These are like $500,000 RVs. If I had more room, I'd throw a picture up at the inside, stainless appliances, decked out with modern interior. Awesome machine, but that's... So I ended up with a practical solution, a Fleetwood Pegasus. Got a really steel on it. You can drill holes in the thing. There's tons of storage space. I'm not going to hurt the thing by drilling holes. And it was very, very affordable. And I can pull it with any vehicle, pretty much. So I named my project Trailer.io and came up with a logo. And so the idea is, again, the initial thought was to take this trailer, this mobile environment, and to deck it out with sensors and actuators, web applications running internally, collecting data, visualizing data, and doing it with as much JavaScript as possible. So I did some research. I talked to a few RV owners, talked to myself a little bit. I mean, I know what I want. And one of the first things I wanted was to get into the alternative energy side of this. And one reason was because I didn't want all these microcontrollers running off of something and having to run a cord from my house. And eventually I want it to be completely self-contained. So I started with the solar battery charge. And I actually do have that running. I couldn't bring that in today. So you're going to see these little prototypes with LEDs and stuff, and you're just going to have to use your imagination. I wasn't going to bring in a 100-watt solar panel. I do have pictures. But this is kind of the order of which I'll probably go, at least it is today. I want to hook up a wind turbine next, and then move into some of these others. So I want to ask a question, and I have no idea how you guys are going to answer this. It could be 2 of you, it could be all of you. But how many of you own an Arduino? Okay, so about 15 out of 40 or 50 or however many. Okay, how many of you own some other type of microcontroller? Okay, it's kind of the same people, I think. Okay. So I'm hoping that some of you that don't own an Arduino at least know what one is, right? Because I'm not going to be able to go into great detail, but Arduino has a whole line of microcontrollers, probably 15 or so. The most common is the Uno. What these are small computer sets that you can hook up to your computer. They give you an IDE. You can push data over the serial port to the Arduino. These little digital pins, there's digital pins and there's analog pins where you can gather data with sensors, and you can also actuate. So I've got 2 really basic setups here using LEDs as an actuator. It's a pretty common deal. And then a infrared motion sensor as the sensor. But use your imagination. You can do anything with there's all types of, I've got current sensors, flame sensors. I'm blanking on there's tons of different types of third-party sensors you can add to this board. This is one of 3 boards that we're going to look at today. Okay. So trailer. Well, one of the first things I wanted to do was, if you've ever used Arduino, there's this Arduino IDE, and it's ugly and it's just annoying, and you got to launch it, and it's a native app to your local computer. And really, one problem I wanted to solve was I wanted to be able to edit sketches. Now, a sketch is a program that runs on the Arduino. So you compile locally and then you upload over serial a sketch to the Arduino board. And I can show you just real quick. Those of you that have Arduinos, this is, oh, I have something running. But basically, you compile and upload sketches via this IDE. So the first thing I wanted to do was I wanted to create like what I was calling it, for a little while I was calling it an app store. It's really not an app store. So I'm calling it a sketch store now. And it's a web-based store that you can grab different sketches, alter them, and then upload them over WebSockets to a node server that then can interact with the Arduino board. So right now my board has got a sketch on it, but I want to. Okay, so I want to be able to take a really simple sketch that blinks an LED on pin 13, and I want to edit it in a online or a web-based editor. This is actually Ace Editor. And then I want to deploy it here. And right here, if everybody can look, you're seeing the red light start to flash on the Arduino board here. Now, if I go in and change that pin, I got it rigged up here to where pin 12 is green. You'll see that switch to the green bulb. Can everybody see this at all? It's kind of hard to see. And then now I'll switch it to 11, which I've got hooked up to a yellow LED. And I was going to do like a Google Hangout on another computer so you could, but anyway, here's the yellow light flashing here. So let's walk through exactly what's going on there. So I've got Ace Editor, which I thought, has anybody of you used Ace Editor or some one of these tools? Like, this is from Cloud9. The company does the web IDE. It was amazingly simple to use. The API was awesome. It took me about half an hour to get the editor side of it hooked up. I push an object over the WebSockets to a Node app, and then I parse the JSON. It's following some specification. I'll show you that in a second. It's a homegrown spec. I use the file system APIs to then grab a template off the file system, set some environmental variables, do a make, and do a make upload, and that's how I pull off that little demo. So the ACE editor was extremely simple to use. I mean, really, this is just a div, an ID on a div, and I set a theme, and I get the session and set a mode, and that C underscore CPP is a C++, so that's why it's properly formatted in the editor. That could be JavaScript or any language, Ruby or anything. This is the spec or the sketch object that I created. So on the click of that deploy button, basically this is the coolest part of the ACE editor API is that I can just grab the value of that sketch in the DOM, assign it to a variable. Later on, I push it into this object down here. But I've got a global trailer and a global trailer environment. Now, I don't have this hooked up yet, but what this is going to do, you'll notice that it's plugged into the object down here too, is this is going to hold IP addresses of other Arduinos or microcontrollers within the environment. And IP addresses and descriptions of what they are, what kind of microcontrollers they are. When this object gets pushed over to and gets built and uploaded server side, the Arduino is then going to be aware, and I call it environmentally aware, of the other microcontrollers in the environment. And that's going to be and you'll see later on that that's kind of the bread and butter of trailer. Here's the template, still very simple. I used EJS, which is a Node, or it's not Node specific, but you see it used quite often in Node. It's a Node module for templating. Just do some dynamic replacements, and then I use the file system API. Any of you guys that are Node guys here probably say, why isn't he using Node streams? I am using Node streams in my next version 2 app, which isn't quite ready yet. But this was a quick way to just get the job done. But Node streams will actually give you access to events, and then I could do things like processing and basically push events back to the browser, so I can give some feedback to the user that the actual sketch is getting built and uploaded. And then Node streams are just a nicer API to work with. I open up a child process to actually run these commands. So any of you Linux guys will, I'm just cding into a directory, doing a make and doing a make upload, and then running execute on that command. A little bit more involved here. I set some environmental variables there. But really, that's the gist of it. Okay. So now what I want to do is I want to show you, the next demo is going to be my intro into using Node to communicate with the Arduino. So the first project I came across was a project called Nodeduino. I knew nothing about this at this point. And so I started digging into the code and looking at how it was working. And here's a little diagram of how it works. So I'm running Node on my local machine. I've got a library called Duino, which is a wrapper, an API wrapper for communicating or writing in JavaScript what you would write in C++ here. There's Node serial port, which is what made all this possible, and I'll show you that here in a second. And then there's also this sketch that you have to push out to the Arduino called Duino, which gives you your interface. So let me go ahead and push that guy out manually here. Okay, so now the Arduino board has a new sketch on it, which the Node module running on Node can communicate with over the serial port. Now, Nodeduino is a guy named Sebastian Miller, or however you pronounce that, created this way to use Duino, but from WebSocket. So what he did was he just created web interfaces that you can then click a button and send over a WebSocket and then communicate with the board. Or you could just do it on the Duino side, on the Node side. But this gives it another layer and makes it pretty slick. So the idea is I click connect here. It's trying to connect. There you go. And then you can see that the red light is flashing here. It's blinking the LED. It's connected. Let's go ahead and jump into the console real quick so we can actually see the frames, the WebSocket frames going over the wire. Should have done that first. Let's just do that real quick again. Okay, there's your, if any of you used this, used the WebSocket in Chrome. Okay. Shouldn't have refreshed. Why did I do that? There you go. So there's so what's happening here is Node is actually now communicating with the Arduino, and it's the browser is sending data through the WebSocket to the Node server, and now it's reading or it's writing to Duino, telling it to blink the light. So I discovered that, and I said, well, that's pretty cool. What's next? Oh yeah. Okay, so that's kind of what I just said. There's a serial protocol is defined in Arduino. The board object is an event emitter. So if you're familiar with event emitters in Node, it produces some, and we'll see this in code in a second. It exposes some events. And then you're seeing the client send data through the WebSocket. Now, serial port, written by Chris Williams, was what made all this possible. He created a Node module that said, I can actually, it's real simple. You just declare the actual serial port and the baud rate, and then you can communicate with any device that can handle data over serial. So this is why you're seeing, like you see Node copters and you see Node drones and all. They all are based off of serial port. Like they're all dependent on it at the lower level. Like I was saying, it's an event emitter. So I get nice syntax like this, pretty standard stuff, looks a lot like jQuery, right? You get an event and you get a callback function. There's the Nodeduino abstraction where I actually have a board object. And I put this in here because Sebastian wrote it pretty well. He used require.js to define all of his modules using asynchronous module definitions. And so you can kind of see that this is actually a LED script that depends on digital outputs. So it's well written if you want to go look at that. And what did I put this in here for? This is actually the socket part of Nodeduino. And you can see here, it's receiving a message, but it's also emitting responses back up through WebSockets back to the browser, saying ready and ready. And I commented it out, but there's actually a failure one here saying it failed. Okay, so that's kind of the intro to Arduino. Then about a year ago, I ran across another board called the Beaglebone. How many of you are familiar with the Beaglebone? Yeah, so the Beaglebone basically kind of changed my mind about, Arduino was neat, but this actually is running Linux, right? So in this current setup that I just showed you, I have to run Node on my laptop, and then I communicate across a serial port to the Arduino. Well, with a microcontroller like this, and this is the size of it, if y'all can see that, it's just a little, looks a lot like an Arduino. But basically, I can now I can hook up a monitor and keyboard, similar to the Raspberry Pi, which we'll look at in a little bit. I've got a lot of pins here, 46 pin headers. So I get access to, I can actually get sensor data here, I can actuate from here. But the coolest thing for me was I could run Node on it. And I could even install MongoDB, which kind of blew me away too. It also ships with Cloud9 out of the box, which is kind of I wouldn't get too caught up in that because you end up, at least for me, in order to get the latest version of Node, I think it was shipping with Node 4.7 or 6.14 or some older version. And so I had to reinstall it all anyway myself. But it's nice to be able to have, to log on to this little device, tunnel into it, or hit it from a browser and get a web IDE that I can go and edit code, which was really, it was novel at the time. So now what I want to do is node to node. So I want to communicate from my, what did I just do? Yeah. I want to communicate from my node server running on my laptop, which is communicating with the Arduino, and I want to push data over to the other microcontroller. And what I'm starting to do is starting to emulate my larger ecosystem that's running inside of my RV. I'm showing you the building blocks. Okay, so we're going to kill this guy, and then I've already got Node running on the Beaglebone. And then I want to, what do I want to do? Oh yeah. In that diagram, I have to, there's a couple of things I'm going to do here. I'm going to show you a new library called Johnny5, which you've probably seen Rick Waldron's robots, NodeBots. But the core of what he's doing is he's using a protocol called Fermata running on the Arduino, which then gives him the ability to do a whole lot more in a lot cleaner way in Johnny5. So let's launch this. The Node server is running on the Beaglebone. I'm going to switch over to Johnny5. Okay, so I've added a couple things, and let's just review what's going on. Fermata protocol is running on the Arduino. There's a Fermata module running in Node, and Johnny5 running on top of that. I've added a motion sensor, and then we'll also talk about the Beaglebone actually runs has a Node module called BoneScript that can get access to all of the pins on the Beaglebone. So this motion sensor I actually put right here, and as I interact with it, you'll see the red LED flashing, and then it's pushing or posting data over to the Beaglebone, which is causing this green light to come on. Now when the motion stops, you should see the red light stop flashing, and then the yellow light on the Beaglebone come on. So all I'm demonstrating here is that now I can have multiple Arduinos in a system or in an ecosystem, and I can have them push data over to a central hub, Beaglebone. Now, that's how it looks. Johnny5 looks very similar to Arduino, and you've still got a board object. But basically, I flash that light. I set up the motion sensor on pin 2. On the motion start, I strobe the red light, which you're seeing the red light strobe, and then I do a HTTP post to the Beaglebone. But some of you are probably like, why are you using HTTP to push data from one to the other? Just because it was easy, right? As this evolves, I'll probably use TCP or some other protocol that makes more sense, not having to hold on to all the header data and all of that. Now, BoneScript runs on the Beaglebone and looks very similar. Here's how you access the pins on the Beaglebone, and I've got those two LEDs. And it's just sitting, this is an Express app running on Beaglebone, and it's sitting waiting for a post. This is your route. I push data over here. I respond with, hey, I got your motion data. And then I change the pins based on the type of data that was pushed to it. There's two pieces of data, a motion start and a motion end. So, conclusions. All right, so now I've got an Arduino communicating with a Beaglebone, two very small little devices. The serial cable is extremely annoying, having to communicate and having to have this host, this large laptop. That's annoying, right? I want to get rid of the laptop. I don't want to be tied to it. The bone is pricey. It's $89 plus shipping, so you're at $100 just to get the bone. But I have it, so maybe it'll make a good hub. So then I discovered the Raspberry Pi when it came out. $35, very similar to the Beaglebone. And I said, well, what is this guy going to do? What's the pros and cons with this unit, right? Processors are pretty much similar. It has less pins, but actually my talk is already obsolete because they just came out with got it on my phone. There's two add-ons. Does anybody know the two add-ons that just released for Raspberry Pi? I'm forgetting the names of them. But basically, they extend the pins and make this much more Arduino-like. And the reason why I say I'm obsolete already in the last week or so is because this was the design that I've been pushing forward with, and that is to sync a Raspberry Pi with an Arduino, getting rid of my host computer. Actually taking my host computer and shrinking it down to, if you haven't seen a Raspberry Pi, I don't have it hooked up here, but now my host computer is this size, right? Instead of having to have a laptop. And when you marry these two guys together, I can run the Arduino IDE on here, I can tunnel into him, run the Arduino IDE, and he can communicate over serial with the Arduino. So everything is shrunk down, I can put a nice case around it, I can set it in the RV, tunnel into it, makes for a nice, you get the best of both worlds. Oh, the Raspberry Pi board or add-on is called the GERT board. So that could potentially reduce or eliminate my need for even having to have an Arduino. That's questionable though. So I didn't have the ability to show you this here today, but you can see right here, I'm on the Raspberry Pi, I'm tunneled into it, and it's kind of blurry, but these guys are linked together, and I'm pushing, basically I'm pushing data back and forth between the Pi and the Arduino, using Johnny 5 as the JavaScript API to get access to the Arduino and Node serial port. This is just a little bit more evolved. There's all these shields that you can get for Arduinos. So this is a Servo Shield and an Ethernet shield underneath. And you can see that you can get a little bit more evolved. You can actually run web servers on the Arduino, but I want it to be a node server. That was the whole point in the beginning. Okay, so this is like a diagram of my current setup, and this is what I've been trying to evolve this whole talk into. Is you've got the Beaglebone running in the middle here, and you've got you've got node servers with Raspberry Pis and Arduinos that can communicate back and forth, and then you've got your Arduino boards, your just plain Jane Arduino boards. You've got I think this is a FIO and a LilyPad and a Mini. So you have all these ways, and they're all aware of each other in the system. And so let's look at the this is, could have showed you that a little longer. Trailer admin is what I call the application that runs on the Beaglebone or in the central aspect of the ecosystem. And trailer admin gives you a couple of things. So, and I've got a couple of versions of this. I'm showing you my first version just because it's the most ready but to give you an idea what it would look like, and this data is dummy data right now on this particular screen, but you've got your profile of your RV, you've got some data, bus activity, what's going on, what's logging on, and you're pushing all, because you're running, it's just a simple little web app, really. It looks nice, but it's really not all that complicated. It's got, an HP connection and a socket connection on the back end. So I can do things like this, HTML5 canvas. When I add an Arduino to the ecosystem, remember that sketch object or that trailer environmental object I showed you in the beginning? You can put coordinates to where each one of these guys is located. So right now I'm going to show you a very simple demo of what I mean by this. So in the trailer, there's a cabinet where I have most of the Beaglebone and the equipment behind two cabinet doors. Well, it's perfect to pick up. If somebody opens the doors, you can pick up the motion, and you can pass that motion, just like I just showed you, to the node server, and then you could even text or send an email. Basically, you've got access to a whole lot of different events there that you can tie into. So let's just show this demo. Cravens running. All right. I've got, okay. So if this works, if I have it set up right. So that's connected. It's a calibration event that's firing right there. Motion end event, so there's no motion right now. But if I do create some data, create some motion, you can see that the HTML5 canvas gets updated through the WebSockets. And like I said, that's just a very simple demonstration. Now the motion event stopped. Start the motion again. So like I said, I'm planning to grow this. This is going to be like a central place where they can gather data and visualize the data on an HTML5 canvas. And if you've worked with Canvas, this is just a CSS background image. I'm using a library called Kinetic.js. Makes things a little simpler. I'm not a huge fan. I wish there was a more robust library, but it's what we have to work with right now. There's another one called Fluid, I think, that I'm also looking at. But this is the idea. There's your Kinetic object or high-level namespace, and all I'm doing is on a socket event, when the motion start gets sent over the socket, I just start the animation. It's really not all that complex, but you can see, use your imagination a little bit, that can grow tremendously. Okay, so I think we're getting close here, and I want to talk about next steps. So I talked a little bit earlier about right protocol for the right job. Right now I'm using all HTTP. It's not efficient. It works. Sockets, I do like the way I'm using sockets. I don't like the library. I don't like using Socket.io. I want to switch to node streams, use something like Shoe or a different type of socket, socket API library. Wireless deploys to the Arduino. So you notice that I was able to go into Ace Editor, change a sketch, and then push it, but I was connected. So there's actually 3 different ways to do wireless deploys, And the one I'll probably settle on that's the least ugly is using the XB or the Zigbee protocol to do wireless pushes. Basically what that is you have a wireless module running on the Raspberry Pi, not the Raspberry, yeah, the Raspberry Pi. In the system I showed you, would be the Raspberry Pi. And then the Arduino has a wireless shield, and you put the other XP module on the wireless shield, and you can push across the serial connection. I was working with somebody on this, and we had it all set up, but we had to use FIOS, and we never actually got it working. So that's one of the things on my list to actually get it working. You can also do a master-slave setup where you have one Arduino as a master, one Arduino as a slave. Kind of an ugly solution. Wireless deploys to the Pi. So because I have a node server running on the Pi, really all I need is like a private NPM. If you guys are familiar with NPM, it's package management, right? So really the sketch or the program that will run on the Pi can just be a node module that I can dynamically add to the node app. And that's the idea that I want to pursue on wirelessly pushing to the Pi. I talked about node streams. Offline first app. So I talked about a trailer admin app that I was creating that's my version 2. Well, one of the things that thinking about creating applications to run, web applications to run on something like this, is you start to think about how to architect it, right? The whole offline first movement actually lends itself nicely to where it's actually offline first and single page app, really, is the kind of the fusion of the two. Basically, I want to push out one load of the app to the browser, and then from there, I want it to be all API calls. I want interactions to use something like Backbone or Ember. If you're not keeping up with Ember.js right now, I'm extremely impressed with this library or framework. It's really becoming, I think it's going to be the go-to for single-page apps. So my version 2 is written using Ember. Of course, they just did a whole API change like 3 weeks ago or a month ago. So it's kind of hard to keep up with right now, but that's getting better. So anyway, the thing that I really want to focus on is optimizing applications to run on, web applications to run on something like this that doesn't have a whole lot of power, but you can just think about pushing out almost like a binary, native binary. I can push out a web app to the browser, and then there's no refreshes after that, and everything is data is all stored in the cloud, so I don't have to run a database on it, and I'm really close to having that ready to go. We have like 2 minutes. Real quick, this is my most evolved hardware piece of the system, and that's my solar charge stuff. Just so you can see that that you can evolve this sensor stuff a lot more than what I'm showing. I'm only showing this little bitty motion sensor. I actually have a 18 volts, 100 watt solar panel hooked up to a 12 volt battery, and I have this circuit that's running to my Arduino Uno, where I can. There's also a charge controller in the middle. I don't know how many of you guys know about solar energy. It's kind of obviously a whole other topic than anything web. So I had to learn all this, but basically I was able to monitor the charge of this battery as the solar panel was charging it and get a read on it in Arduino using a voltage divider. And this voltage divider just pairs down this 12 volt to something that the Arduino that can understand, and then the sketch running on the Arduino computes it back to a number that's closer to in the 12 volt range. And so here's the serial port reading out the charge of the battery. So here's the C++ sketch. One one of the next things I want to do is convert this to Johnny 5 and put this in JavaScript and publish it out to the community so that people can use a Raspberry Pi to drive that interaction. But this is just the starting point, right? So getting the current charge of the battery is just one thing. I also want to know what the pull is off the RV on the battery, right? So I've got that Hall effect sensor right here, which allows me to get a read on the current being pulled by the refrigerator, by the radio, by the lights. And then I can pump that over to a different pin on the Arduino and send it over to the web app. And then I can get a visual of that. And then I want to have the amp hours left on the battery, right? And that's another data point, which is just another calculation. And then finally, I want to convert it to a percentage. So I could get something like 79% of the 100-watt max capacity is available on the battery. And so that's where I'm going with that side of things. Lastly, I'll say I owe the open source community quite a bit, so you're going to see a lot of this stuff being pushed out. If you want to keep track of it, if you're interested in knowing more, just watch my Twitter account. It's JD Cravens, as I showed you in the beginning. I'll be doing updates like that. So if you wanted to get the latest, it'll all be on GitHub and it will be, available. And I'd love to have anybody else contribute. Lastly, I've got more of these books in the car if anybody wants one. Just to give you an idea, there's 90 hacks in here of most of the HTML5 specifications. Great starting point if you're trying to get caught up in HTML5. I'm not trying to make a lot of money on these, just whatever you can. So, thank you.